In our previous lesson, we learned how to solve quadratics that were written in this format. A base squared equals to a number. And we learned that to solve this type of quadratic, you just take the square root. In our first example, our base was just an x. We had x squared equals 64. So it was relatively simple to solve, just one step, just taking the square root. Well, this time we're going to have a little bit more going on with the base. The process will be the same, but just with a couple extra steps. Let's take a look. So if our base is x minus 5 this time, we have a little bit more going on, but still raised to the exponent of 2, so still going to be set up in the same format. And that equals a number, let's say 49. Okay. And our method, of course, is to solve by taking the square root, which is going to undo that exponent of 2. I'm just going to write this over so we have a little bit more space to work with. Now I'll take the square root of both sides, okay, because I want to undo that exponent of 2. And now on the left side, I'm left with just the x minus 5. And over here, the square root of 49 will give us 7, but remember, we'll have a positive and negative 7. So we can write it as plus and minus 7. Now we're not done solving this equation because x isn't by itself yet. So we're going to need to do something a little bit different to continue on solving this equation. Because we have x minus 5 is equal to two different numbers, positive 7 and negative 7. So to deal with that, we'll split it up into two separate equations and solve those. Okay, we'll have x minus 5 equals the positive 7 as one equation, and x minus 5 equals negative 7 as the other equation. And now we have these two simple little equations to solve, just one-step equations. You can get x by itself by just adding 5 to both sides of this equation. You'll have x equals 7 plus 5, which is 12. And then we'll solve our other equation. Same steps. Add 5 to undo that minus 5. Do the same thing on both sides. Now we have x equals negative 7 plus 5, which is negative 2. Okay, so now we have our two solutions, 12 and negative 2, which we can write in set notation if you want to write it in a fancy way there. Okay, where we just write our two solutions listed in the curly brackets. Okay, and it's always a good idea to check your answer though. So we have these two solutions. To check them, we can just plug each solution in for x in our original equation and make sure that it works. Let's see how that goes. Okay, so first I'm going to test out the 12. Let's plug in 12 for x there. I'm just going to write everything else the same, just replacing the x with the 12. Okay. And then I want to see if that equals 49. If it does equal 49, then I know that 12 is a solution to this equation, but I'm not sure yet, so I'm just going to put a question mark there. Let's see if this works. We'll follow the order of operations to simplify this left side. So inside the parentheses, we start with 12 minus 5, gives us 7 squared. And does that equal 49? It sure does. And let's test out our other solution, the negative 2. We'll plug that in for x. So we have negative 2 minus 5 squared. And then we'll see if that does equal 49. Okay, Okay, inside the parentheses we have -2 minus 5, which is -7. And I'm going to put parentheses around that, so I remember to keep the negative with the 7. And I want to see if that equals 49. Well, -7 times -7 does equal a positive 49. So that -7 does work as a solution for, or rather the -2 works as a solution for x. So our -2 and 12 both are solutions for x. So we know that this is our final answer. Okay? So just remember, whenever you see a quadratic that's written in this format, and it doesn't matter if the equation is reversed. You can have the number on this side and the base squared on the other side. But if it follows this format, then your method of solving is by taking the square root. All right, great job everyone, and I'll see you next time.